LeetCode 680. Valid Palindrome II isn't just a quirky string puzzle. It reflects real-world tasks like cleaning up noisy data, validating user input, or spotting outliers. But here's the twist. With strings up to 100,000 characters, brute force won't cut it. We need speed and a clever way to check near palindromes. Let's get into it. Let's kick things off with the classic brute force move. We'll try removing each character one at a time and check if the new string is a palindrome. It's not pretty, but it helps us see what's possible. So we scan through the string, trying every position. At each step, we simulate deleting just one character, testing every possible what-if case. Each time we delete a character, we form a new string. That gives us a clean slate to check whether that version forms a valid palindrome. Once we've got the modified string, we run a check. Is this a palindrome? If yes, no need to look further. We've found our answer and can return true right away. If none of those single deletions do the trick, we've got one more option. Maybe the original string didn't need fixing in the first place. Let's check that. To help with this, we define a helper method that checks if any given string is a palindrome using a simple two-pointer scan from both ends. While scanning, if we ever hit a mismatch between characters, that's our signal it's not a palindrome, so we bail early with false. But if we make it through the whole scan without mismatches, we know the string is a palindrome and return true. The brute force approach runs in big O of n squared time. For strings with 100,000 characters, that means billions of operations. Plus, we copy strings each time, so we're using big O of n space too. It works, but it crawls on long inputs. Let's trade that slog for something sleeker. We'll still use two pointers, but this time we only skip when absolutely necessary. We set up two pointers, one at the start, one at the end. These will move inward, comparing characters as they go. As long as the pointers haven't crossed, we keep checking characters from both ends of the string. If we hit a mismatch, we've only got one shot. Skip a character on either the left or the right, and check if either resulting slice is a palindrome. But if the characters do match, no need to skip. We move the pointers inward and keep checking. If we finish without ever needing a skip, that tells us the original string is already a palindrome, so we return true. When we do need to skip, we call a helper that checks whether a substring, defined by left and right bounds, is a valid palindrome. This helper works just like before, two pointers comparing from both sides. If we hit a mismatch, we return false immediately. But if we make it through without mismatches, we've got a valid palindrome on our hands. This optimized version runs in big O of n time with big O of one space. No extra memory, no slicing. Just a single pass through the string, blazing fast and interview ready. We began with a brute force approach, deleting one character at a time and checking each version. It's simple, but with big O of n squared time, it drags. Then we switched to a sharper strategy. Two pointers, one skip, constant space. It's a huge leap in speed and memory use. And that's not just a LeetCode trick. This is the kind of logic real systems use to pass logs, clean inputs, and handle noisy data fast. In a FAANG interview, pulling off that pivot, that's what makes your answer stand out. So try building the two-pointer version yourself and think big. Where else could this pattern shine? Keep solving and quack on.